In a step towards creating a new class of electronics that look and feel like soft, natural organisms, mechanical engineers at Carnegie Mellon University are developing a fluidic transistor out of a metal alloy of indium and gallium that is liquid at room temperature. From biocompatible disease monitors to shape-shifting robots, the potential applications for such squishy computers are intriguing. Until recently, the only example of liquid electronics were microswitches made up of tiny glass tubes with a bead of mercury inside that closes the switch when it rolls between two wires. Essentially, the fluidic transistor is a much more sophisticated switch that's made of a liquid metal alloy that is non-toxic, so it can be infused into rubber to create soft, stretchable circuits. Unlike the mercury switch, where tilting the vial closes the circuit, the fluidic transistor works by opening and closing the connection between metal droplets using the direction of the voltage. When it flows in one direction, the droplets combine and the circuit closes. If it flows the other way, the droplet splits and the circuit opens. Researchers Carmel Majidi and James Wisman of the Soft Machines Lab at Carnegie Mellon say that alternating the opening and closing of the switch allows it to mimic a transistor, thanks to the phenomenon of capillary instability. The hard part was inducing the instability so the droplets change from 2 to 1 and back seamlessly. We see capillary instabilities all the time, says Majidi. If you turn on a faucet and the flow rate is really low, sometimes you'll see this transition from a steady to individual droplets. That's called the Rayleigh instability. By testing the droplets in a sodium hydroxide bath, the engineers found that there was a relationship between the voltage and an electrochemical reaction where voltage produced a gradient in the oxidation on the droplet's surface, altering the surface tension and causing the droplet to split in two. More important, the properties of the switch acted like a transistor. We have these two droplets that are analogous to source and drain electrodes in a field effect transistor, and we can use this shape programmable effect to open and close the circuit, says Majidi. You could eventually use this effect to create these physically reconfigurable circuits. The researchers say that the new fluidic transistor opens up to prospective miniature liquid computers that are biocompatible and can interface directly with body tissues to act as disease monitors or help stroke patients restore their brain functions. In addition, liquid circuits could allow materials to be reconfigured to change their functions or bypass damaged areas. It could be on a structure that's undergoing some very large physical deformations, like a flying robot that mimics the properties of a bird, says Majidi. When it spreads its wings, you want the circuitry on the wings to also deform and reconfigure so that they remain operational or support some new kind of electrical functionality. The research was published in Advanced Science.